Today we're going to look at how to solve trig equations involving multiple angles. And once again, we're going to restrict our values from 0 to 2 pi and don't include 2 pi. And if you look at this graph here, you'll see that from 0 to 2 pi, we actually have 6 solutions, or 6 x-intercepts, or 6 roots, whatever you want to call them. And the reason that happens, when we graph this equation down here, if you were to just graph 2 sine of theta minus 1 equals 0, you would actually only get 2 solutions within this restricted value. The 3 actually shortens our period. It scrunches the graph together, so now I actually have 3 times as many solutions. If this was a 5, I'd have 5 times as many solutions. Alright, if it was a 1/2, I'd have 1/2 of the solutions. Alright, so what we're going to do is take a look at how to solve this equation and get these x-intercepts. Alright, so just like any trig equation you've been solving, you want to isolate the sine 3 theta. So we're going to have the sine of 3 theta is equal to a positive 1/2, and we're going to hold off on this 3 theta. We're going to solve this as if the 3 theta doesn't exist. And where does sine a positive 1/2? Well, that happens at pi over 6 and 5 pi over 6. So we have 3 theta is equal to pi over 6, and we have 3 theta is equal to 5 pi over 6. Now that only gives us 2 solutions. We have to get 4 more, because remember there was a total of 6. So what we're going to do is, with the pi over 6, we're actually going to add a 2 pi to that. So if you take a pi over 6, 2 pi, I'm going to write as a 12 pi over 6. And we're going to add that to pi over 6 to get 13 pi over 6. And add another 2 pi to that as well, to get a 12 pi, and 13 pi is a 25 pi over 6. And we're going to do the same thing with the 5 pi over 6. We're going to add 12 pi to that to get 17 pi over 6, and another 12 pi will give us 29 pi over 6. Alright, and now keep in mind, if this was a 5 or a 7, I'd have a total of 5 up here with the pi over 6s, and I've had another 5 down here. Whatever this number is, that's how many you want with each of your original solutions. Now remember, this is a 3 times theta, so I have to divide each one of these by 3. And when you divide by 3, it's the same thing as multiplying by the reciprocal. So it's like multiplying by 1/3. So pi over 6 times 1/3 is going to be a pi over 18. For 13 pi, it's going to be over 18, and then 25 pi over 18. And the same thing happens with the values at the bottom. You get 5 pi over 18, 17 pi over 18, and 29 pi over 18. Right, and there are your 6 solutions. Alright, let's take a look at another example. Once again, let's isolate the secant 2 theta. We'll have the secant of 2 theta. If I subtract 8 and divide by 4, I'm going to have a negative 2. And once again, hold off on this 2 theta until the end. Working with secant's a little difficult, so let's take the reciprocal of this. The reciprocal of secant is cosine 2 theta, and the reciprocal of negative 2 is a negative 1/2, because that's a 2 over 1. Now this is a little bit easier to work with, and just like the last problem, we're going to take 2 theta is equal to, and 2 theta is equal to, and you have to find out where's cosine negative 1/2. It's negative in the second and third quadrants, and it's negative 1/2 at 2 pi over 3 and 4 pi over 3. Alright? And because I have a 2 times theta, I want 2 answers for each one of these, so I'm going to add a 2 pi to a 2 pi over 3. To get common denominators, that's going to be a 6 pi over 3, so a 6 and a 2 is going to be an 8 pi over 3, and if I add 6 pi over 3 to 4 pi, I'm going to get 10 pi over 3. And once again, I have 2 times theta, so I'm going to divide everything by 2 on both of these, which is the same thing as multiplying by 1/2. So I'm going to get 2 pi over 6 and 8 pi over 6, and then 4 pi over 6 and 10 pi over 6. And there are our 4 solutions. I guess we should probably reduce these. 2 pi over 6 is going to be pi over 3, and 4 pi over 3 and 2 pi over 3, and 5 pi over 3. Alright, so those are your reduced solutions. Alright, our last example here, we have 2 times sine squared 1/3 x equals 1. And once again, let's isolate this sine squared 1/3 x. So I'm going to have sine squared 1/3 x is equal to 1/2. And once again, we're going to leave the 1/3 x. Don't mess with that. Let's undo this squaring. So I'm going to take the square root of both sides. So I'm going to have the sine of 1/3 x is equal to plus or minus the square root of 1 over the square root of 2, which is just sine of 1/3 x is equal to plus or minus. This is 1 over root 2. You're going to have to rationalize that denominator. So multiply by root 2 over 2, root 2 over root 2, and you'll get root 2 over 2. So now, where is sine root 2 over 2, and where is it positive and negative? Well, it happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So we're going to have a good handful of solutions here. We're going to have 1/3 x is equal to pi over 4. 1/3 x is equal to 3 pi over 4. 1/3 x is equal to 5 pi over 4. And 1/3 x is equal to 7 pi over 4. Now, because this number here is a 1/3, it's only going to, the most amount of solutions you're going to have are these 4, if we stay within our restricted value from 0 to 2 pi. But to get rid of this 1/3, I'm going to have to multiply all of these by 3 to undo the 1/3. So 3 times pi over 4 is a 3 pi over 4. Here we'll have a 9 pi over 4, 15 pi over 4, and lastly 21 pi over 4. And if you look at these, 8 pi over 4 would be 2 pi. So these are all outside of our restricted value. So the only solution from 0 to 2 pi is 3 pi over 4.